Hello students, myself Suraj Gupta, an assistant professor in mechanical engineering department at MLV Textile Engineering College, Bhilwara. Today we are going to start the fourth lecture of transmission of power. This topic is from the fourth unit of Basics of Mechanical Engineering. Have a look over what we have done in the previous lectures. In the lecture 1, we have done the basic concept of power transmission. We derive the formula for velocity ratio for simple belt drive for two cases, that is slipping and non-slipping condition. And third is we did some practices of the numerical problem depend upon these velocity ratios. And in lecture 2 we derived the formula for total length of the belt in open belt drive, and we did practice numerical on the total length of the belt. In lecture 3, we derive the formula for total length of the cross belt drive. We have seen this formula just as a open belt drive, and we understand the tension in the belt, and we derive the relation of tension ratio with the coefficient of friction and angle of contact in simple belt drive. Now in the fourth lecture we will see the power formula in the belt drive, and we will derive the equation of the formula for the centrifugal tension, and we will study the centrifugal tension in detail. So what is the power transmitted by the belt drive? Now we have decided that this is the slack side and this is the tight side, as this is the driven and this is driver. So this is tight side and this is the driver, and the power is to be transmitted to the driven pulley with the speed having the driver is omega 1 and at driven it is omega 2. So if we take any of the pulley, we can see that this is T1 and this is T2, and it is rotating in the anti-clockwise direction. It is anti-clockwise direction. So we have to find out what is the torque, total torque, or you can say that resultant torque. We can see this is a force and this is force, and both forces are trying to rotate the pulley. This force is trying to rotate in the anti-clockwise direction, and this force is trying to rotate in the clockwise direction, but the pulley is rotating in the anti-clockwise direction because T1 is more than T2. So what is the total torque? This is anti-clockwise direction torque minus this clockwise direction torque. So what is the anti-clockwise direction torque? T1R, force multiplied by perpendicular distance, and minus T2 into R. So the work done by this torque will be same. The work done equals to force multiplied by the perpendicular distance. So this is force T1, and this is minus T2 because it is clockwise, and this is anti-clockwise, but resultant is anti-clockwise, so T1 is greater than T2. So T1 minus T2 into R is the torque, and this torque is responsible for the work done of the pulley. Then we can find out the power. Power is defined as the product of torque multiplied by angular velocity. So T into omega is angular velocity, and we can say that if this is a force, resultant force multiplied by this R, and R multiplied by omega means here torque, there is a T1 minus T2 into R. So R omega will be linear velocity, that is belt velocity, and T1 minus T2 will be force. So force multiplied by linear velocity will also give us power, and torque multiplied by angular velocity will be power. So I have a question for you, that what it is driver or driven? See the direction of the T1 and T2 and see the direction of rotation of pulley, and decide this, is it driver or driven. Now we have the formula power equals to T1 minus T2 multiplied by R into omega. This R omega is linear velocity, and this T1 minus T2 can be termed as a force, resultant force. This force multiplied by R omega means force multiplied by linear velocity, VB, the belt velocity. So the power equals to T1 minus T2 R, and we can replace this omega by 2 pi n by 60, and this is the torque. We are going to and we should not be confused with this T and this T. This is torque and this is tension. This is tension. So I have given the different notation for the torque and tensions. So power at driver pulley is 2 pi n dr t dr divided by 60. That will be equals to 2 pi n dn t dn divided by 60. But t dr is a torque at a driver, and this t dn is torque at driven pulley. So what is the torque at a driver pulley? What is the value? It will be the force multiplied by perpendicular distance. This is T1 minus T2 multiplied by perpendicular distance. At the same way, the torque at a driven pulley is T1 minus T2 multiplied by R into R dn. This is torque at driven pulley. So this is the formula for the power in the belt drive. So you have to remember this formula and this formula. Now the centrifugal tension in the belt. What is the centrifugal? The meaning of centrifugal is hypothetical. We can say hypothetical, yeah, or it will generate when a body is rotating at a curved path. The a force is applied on the body, which is responsible to get out from its center of curvature. So this force will apply on the body which is rotating at a certain point. So it is the tensile force generated into the belt due to centrifugal force. When the belt is moving with a velocity, that is, we know that the velocity of the belt is Vb, and we know that the belt is also having some mass. So if it is having mass and it is having velocity, so it will create centrifugal force which will apply in the direction away from the center. So we can see that if this centrifugal force is applying on the belt, so belt will experience some extra tension in these directions, extra tension, because the belt should not be go away from the pulley. So we should experience some extra tension which is responsible for the contact between the belt and pulley. So there will be a tension. This is Tc and this is Tc. So we have already this T1 and this T2, but due to centrifugal force there will be centrifugal tension. This is centrifugal tension. So this T1 will be converted into T1 plus Tc, and this T2 will convert into T2 plus Tc. This tension is added in the both the tension, that is T1 and T2, and that will be T1 plus Tc. Then this value will be T1 max, and this value will be T2 max. Therefore, the tension ratio will be T1 plus Tc divided by T2 plus Tc. That will be equals to E raised to mu theta. This derivation we have already done in the previous lecture. So power will be this tension minus this tension multiplied by R into omega. So this tension minus T2 plus Tc multiplied by R1 omega 1, or we can say R2 omega 2. So we can see that Tc is cancelled out, and we will have the same formula T1 minus T2 multiplied by R1 omega 1 or R2 omega 2. So the power formula will not change if the centrifugal tension is there. Now the derivation for the centrifugal tension means what is the value of this Tc. So we are going to derive the formula for Tc. It is the additional tension developed in the belt in the presence of centrifugal force. We have already known about this. So now I'm going to make a pulley and belt. If only there is a centrifugal tension, so there is a centrifugal tension in this direction. At every point there is a centrifugal force. So if I take this small strip, then also there is a centrifugal tension, but it is tangential. Here it is tangential to this, and here it is tangential to this. If we are assuming this point, then tangential to this. So if we take this strip of d theta, so half angle is d theta by 2 as, and so this is d theta by 2 also. So this is also d theta by 2, and centrifugal force is applying in the direction away from the center, Fc. So in this case we have to balance the forces, upward forces to the downward forces. So what are the total upward forces is Fc only, and if we if we take the component of this TC in the horizontal and vertical direction, the horizontal direction component will be cancelled out. Leftward equals to rightward. TC cos d theta by 2, TC cos d theta by 2, both are will be cancelled out, and we will have the vertical component of this TC in this direction, that is TC sin d theta by 2, and of this vertical component will be TC sin d theta by 2. So there are two TC dies in sin d theta by 2 in the downward direction, and there is upward direction. This is FC. This is centrifugal force. So this is not in use because cancelled out forces, and this will be used. So but before that we have to know that m here, it is not a mass, it is a mass per unit length. So mass of the small strip, m is the mass per unit length, means there is a total length of the bed. So there is a mass of, suppose there is a mass of 10 kg, and if we are taking the length of the belt is 20 kg, sorry 20 meter. So what will be the small m? It will be 10 by 20, that is 10 by 20 is 0.5 kg per meter, 0.5 kg per meter. So what is the mass of the this strip? If we are saying that in 1 meter the mass is 0.5, so what is the mass of this strip? What is the length of this strip? The length of this strip is this is an arc, and this is the radius, and this is d theta. So what is the length is r into d theta. So per unit, per meter, the mass is small m. So for this r d theta, the mass will be m into r d theta. So we're going to see this mass is m into r d theta. Length of the strip is r d theta, so mass will be m into r d theta. You have to remember this, you have to take care about this m is not mass, this is mass per unit length. Now we are applying the equilibrium equation, summation of Fy equals to 0. So the total downward force equals to total upward force. So 2 Tc sin d theta by 2 equals to Fc. Since we also know that the Fc equals to centrifugal force, that is mass multiplied by velocity ratio divided by radius, that is mv square by r. But mass is total mass of the strip. So the total downward force is 2 Tc sin d theta by 2, that is equals to mass of the strip multiplied by v square divided by r. So d theta is very small, so sin d theta will be d theta by 2. So 2 Tc d theta by 2 equals to m into r d theta, which is because the mass of the strip was m into r d theta multiplied by v square divided by r. So Tc will come out, d theta is cancelled out, r is cancelled out, and 2 is cancelled out. So Tc will be mv square. But once again I'm saying that this m is not a mass, this is mass per unit length, and v is the belt velocity, that is r1 omega 1, or we can say r2 omega 2. Now the T1 max, it will be T1 plus Tc, means the centrifugal tensor will be added, and T2 max will be T2 plus Tc. So now the formula will be T1 max divided by T2 max equals to e raised power mu theta. But we have to use the centrifugal tension in formulas if we have to check out the welt velocity, is it greater than 8 meter per second or less than. If it is less than 8 meter per second, then we cannot use the centrifugal formulas, because this will be very less. This will not change any performance of the belt. This will not affect the performance of the belt or power of the belt or tension ratio of the belt much more. So we will assume, we will consider centrifugal tension when the belt velocity is greater than or equal to 8 meter per second. Okay, that's all for the today's lecture. We will continue for the next in the next lecture for the belt drive. in which we will study the initial tension and the tension, the value of the tension for maximum power. So stay tuned for the next lecture. Thank you.